Jupyter Notebook, work Python environment, you were able to install and configure that, right? Good news. So the class can end actually now. Where's my phone? There's a file here. Yeah. It's a group. Oh, sorry. Always late. Download after it has downloaded, you can send to the group, please. All right. All the best in your exams. I am meant to understand that you have exams beginning this week. So all the best in your exams. I think most of us, we were able to run successfully the metgrid file. This is where we ended last time. So the assumption which I'll bank on now is that this process is complete. I'm forwarding some files to your group. Kindly download it even as we continue. Kindly download it. Kindly download the file which has been shared to the WeChat group. My guys, there's no port for me. Let me survive with the power I have for now. Okay. I've never used this one before. Okay. Yeah, I think I'm okay. Let's go to WPS and confirm. Just confirming that all is well. WPS, metgrid. For most people, I think there was a problem with the name list, especially those that were coming from the mid-latitude. So I remained behind, I think, that day to sort one or two computers. And I hope that we are here. Okay? So if we are here, then it means we are done with WPS. And my good Laoshi here told me that I should show the students where we are with regards to no, not here, with regards to the steps and where we are. So is this visible to everyone? Sorry, I just asked ChatGPT. You know, ChatGPT can help shorten. it can help alleviate headaches. So I asked ChatGPT to help me do what we call a workflow. So where are we? We have successfully incorporated the initial conditions from GFS, which for operational purposes you can download from GFS or you can download from error file. The error file, not error file, the ECMWF boundary data, the one we call IFS, their forecasting system, the IFS, does not give the boundary data in real time. So this is a challenge for operational meteorologists the world over, unless you are coming from Europe, unless you are within you know, the European Union. So if you are anybody else, where anybody else means anybody from outside the EU, you pay. You have to make contact so that you can pay. But the GFS files from the NOAA system is freely available. For research, though, both the ECMWF and the grid file is available. But I've said the error 5, the ECMWF one is not available during operations. That is real time, because when we do operations, we need the data within about 15 minutes or 30 minutes. I think ECMWF will archive it after several weeks or thereabout. Then we have incorporated as well the static geographical data. This is the WPS geog file. The process of incorporating the GFS was the one we did geogrid.exe. The part for static geographical data, no, this one is for static geographical data, the WPS job. And then the one for metgrid.exe processes the GFS files. The anagrib is just anagribing, changing the data format. So what we end up with, where we end up with data. We end up with data in our famous cube here, this box, this cube. But where exactly is the data? Where is it placed? So we said that the data is placed in the boundary point. It depends on what we call the grid type. So there's what we call the staggered grid, the horizontal grid, and the other grids, Arakawa grid, and all that. So wherever the data is placed is defined by the grid. Now that is a subject of research. Those that are into NWP, one of the things we do is which is the best place to put this data. That question, if we are trying to answer, is basically in line with the way we solve the question. So the methodology we choose in solving the PD, the partial differential equations, define where we put this, and that differentiates one model from the other. For example, the WRF which we are using uses what we call a sigma hybrid, staggered, Arakawa. Okay, those are many words, but what it does is sometimes we put the values here, but some variables we put at the center of the domain. So those things that I'm saying, where we put data, where we do what, is for now what we want to do next. And what we want to do next is inside the folder WRF itself. Okay. So we want to pick this data which we have processed from the WPS and distribute it according to the defined grid. As we are doing that, we are also going to be performing some QC checks. And as we perform the QC checks, we are also going to do vertical interpolation. So wherever the file was, we also need to define the vertical coordinate. Normally, the metgrid just puts the data in a horizontal platform. So one level, it's usually a one level data set. But The next step which we are going to do will now interpolate this data. So once we are done with this, um, we are going to do this particular interpolation, and then lastly we run the model. This other part is after your exam. So let's start. Let's go. Finally, we are done with WPS. Let's now go to WRF. We have never been here before. We don't know what is in WRF. So let's go to WRF and specifically the folder called run. And we should be able to see these executable files. Really? Okay. We have these executables, right? So go inside WRF run. I hope your WSL is, the folder structure is arranged like this. The folder structure is arranged like this. As we are doing this, let us also bring our wrf.sh script, which perhaps is the most important script I think we've ever dealt with in this class. Let's bring it there. I think mine is where? Mine should be inside files. Yeah. So bring the WRF script also. Let it be open. And where we are going here. Okay? WRF run. Where is your WRF folder? It is where the WPS folder was, but now it's not WPS, it's WRF. For some of you, if it was not renamed, maybe it will be having the extension minus 4.5. Maybe. Maybe it will be like this. Or maybe it will just be WRF. So go here, cd this, and then cd run. Go inside the run directory. Okay? Are we already there? Yeah, we are there. Okay. So the first thing we do, please bring this script because it's very important. So we are here, and now we are running the model. We are going to edit this script much better afterwards, but we are presently here. IMSA build WRF. Okay. The first thing we do is to bring the files we processed using metgrid. You know where they are? They are inside the WPS folder. Now, how do we know where they are? How do we know where they are? So I will show you how to know easily. Link ln minus sf is like linking the file. So we don't need to copy them. Each time we copy them, we increase storage space, storage required to keep them. So we don't need to copy them because they are already stored somewhere. Let's just link them to this directory where we are working from. So link them from wherever they are. I think mine will be at home, NWP, IMSA, build, WRF, WPS. Yeah, here they are. These are the files we are linking. Okay. So the command is link minus sf, then the path to your WPS folder. I can write mine like this, WPS. Then the files themselves are called met_em. Met_em like this. So while not that the dot slash is my path. So you should write your path fully, yeah? So that you point to the direction where your met files are. So we are linking them where? We are linking them here. We are linking them here. Question. Do you have them in your WPS folder? For some people, I'm suspecting for some people, these files were taken to your domain folder. So how do you know? No. The ones in GFS were the ones called gfs.t00, right? We are not linking this one. Sorry, we are way beyond this step. This one we were linking at this point. Now we are done with WPS completely. We are on WRF. We are linking the files we have processed at metgrid, and their names, they look like this: met underscore em, yeah, dot d01, and it has a long name. Be sure that they are in your WPS folder. Okay. So let's link them here. If you link them and you LL, now you can see that you have them here. They are linked. This one means it's linked to another directory. So it's pointing to the directory where we have picked it from. You can see some people still straining to see the command. The command is here. So once linked, you can see them with the LL minus LL minus H or LS. Any of the L command. Even L alone can help you to see them. Is it linked? So after we have linked them, and I've demonstrated how to link them, they will look like this. Met, EM, if yours is red, means it was not linked. Okay, I don't know whether yours will be red. I don't know the WSL interface, how it will look like. Now that they are linked, the next step, so this process in your wrf.exe part, we are here. This part should be edited up to where your files are. So next, this one is just a command to open another terminal, and I want to open another terminal. You can open manually, no problem. I'm holding on, but you had not talked. Okay. Now I'm holding on. I hold up. Huh? Okay. Easy. It is easy. What you do, either check in your WPS folder or check inside Uganda or Tanzania or Pakistan. They can only be in those two places because the name list that we were editing, they either point to your domain or they point to the WPS folder itself. If you don't see these files in your WPS folder, go to your domain folder. They will definitely be there. So let's be quick. Okay? Can I still hold on? How many more days to go? 2 days. ln minus sf home, whoever you are. I think for most of you it's just build work. right? Then from build work, yes. From build work domains, then whoever you are, Uganda, Tanzania, and then you link met, blah blah, and you link here because you should be. This command is being run when you are inside WRF. So met, blah blah blah, and then you end it with a dot. Or all this thing will be inside WPS, just like this. WPS met underscore em blah 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 link here. All, all of them. So you use the star command to pick all of them. So don't write the whole name, just write like this, and it will pick all of them. So once it's linked, there's there's something we need now to edit. Very important. Because you didn't link the right file. So where are my launches today? My launches are not around. I don't want to go down here because once I go down here, our troubles begin, you know. I will get stuck somewhere and then we will not proceed. So the other thing I want us to do is to copy our name list. Name list. Last class, Dinesh helped you to create some name lists, or those same name lists that we copied the last time. You know, you remember from the first day we created name lists. So I want us to copy, but myself I'll not copy because I already have a working name list. I want you to copy from home. Just follow this path until you go to your domains folder. Build wrf domains, right? I'm working on this Switzerland. This script called namelist.input. We want to copy it here. So copy the namelist script here. And then we are going to edit it. Where are we copying it from? From the domains folder. Just copy it. Namelist.input. The other time we were working on namelist.wps. Now today we are on namelist.input. Namelist.input. Okay. So namelist.input, copy it to this folder. We should be able to see the namelist.input somewhere. This one. Copy namelist from domains, namelist.input from domains folder. That is where we are. And then we want to edit it. So with it copied, we edit it, namelist dot. I copied mine again. It's okay. I'll edit it. So gedit the namelist.input. It looks like this. Now, for those that want to do research in NWP, Namelist.input is one major area that you can actually just work on this namelist input and do a thesis on this script alone. This one that I've just opened, because by the time you understand what this namelist is from page 1 to page 112, you will be a top ranking NWP expert in the world. You know? This script, by the time you understand every line, and you can configure it accordingly. So for today, we are going to just configure a little bit of it and then use the defaults. Okay. But major research is here. Now, what is this script? I want to just give a scenario or an example. When okay, I just landed in number 94, for example, this number 94, or maybe we can go to this one. So let's say maybe PBL physics, okay, line 61. Meanwhile, as I'm explaining, the copying should be going on. When I type, you can be taking a quick screenshot, then you do what we are doing, or you can be referring to these lines. They are all here. The linking, I think the copying is done once, so it's not in this routine script. Okay. So namelist.input, I was about to explain, for example, what this thing means. Okay. PBL physics. When we say PBL, but then what is PBL? PBL, planetary boundary layer. Good. So what is planetary boundary layer? The layer within which, let me put it in simple English, just the layer within which weather occurs, active weather. And particularly we refer to the convection layer. Now, this layer here has a lot of processes. There's someone, this person that we are calling number one, you know, this one here, is referring to somebody's research. Okay. What they did, they wrote equations of the atmosphere. Very sophisticated. They are so sophisticated. If you want to know what they are, you go inside the wrf. Just go inside here and see. Maybe let me say, for example, dynamics. You know, there are things that look like this. You know, there are things that look like this. These are Fortran codes. This is just one of the codes here. Let me see another one. Interpolation of domain, module advection. No, not that one. Something like this. WRF model layer dynamics, for example. I'm just explaining what these numbers in the name list refer to. They refer to somebody's research paper. And what those people did in the paper is they describe how the PBL behaves. Basically what we call a scheme. So for example, you hit the atmosphere, then it begins whatever, then wind begins moving like this, then this one happens, then this, then this, then this. So it's a whole scheme of what we call parameterization. We have defined how the PBL behaves, literally, in equations. So we choose to, for this case and for our class, for example, today, what you have here as the PBL physics or as the surface clay physics is basically a choice of what somebody wrote. And we are just calling that function, and it's going to process the atmosphere in terms of the dynamics of surface clay according to the complex equations written by somebody. Now you can choose to write your own and bring it here and then test it. And you will become a top expert. So all these things, I would say almost everything we see in this namelist.input is a result of complex research. For example, if we go to raw physics alone, maybe we have 15 guys in the world over, the world over that have written something about long wave radiation and how it interacts with this variable and that one and that one and that one. So this name list is the subject of research, but what it's saying, it's just saying that we are, for example, picking somebody's description of the cumulus behavior of clouds or thunderstorms, and then we feed it here, and the equations will evolve according to what that guy has written. So this is where the real physics is. This is where now the real integration of the equations, the way we were explaining, that du dt, the total acceleration will be defined by the partial differential equations plus this of u. Actually, it should be what is this? Those that do math. Du dx of the x, du dt of the x plus whatever, of y and of v. So the solution where u here is any variable. So it's not you win. This one can be pressure, this one can be what, this one can be theta, this one can be what. So we write the equations of the atmosphere and we solve them dynamically. And then we feed them into what we call the momentum equation, we feed them into the thermodynamic equation. And the way somebody has described it becomes what we call a scheme. And when we choose one, we are choosing what we call a parameterization scheme. These ones are now for the people who are really now studying these things, and it's your choice if you want to do that. But for now, we work with these defaults. The only thing we are going to change is the time control. The time control. And our data was for 2025. The month was December, and the start day was 13th. I believe all of us downloaded data for 13th, yeah? And start hour was 0. I think 06 for my case, I'm not sure. And we were ending at 2025. End month is December, and end day 13th. We were just running the model for a few hours, maybe 6 hours, maybe for 12 hours. I'm not sure about your name list of WPS. What you wrote there is what we are writing here. So if you are running it for 12 hours, this becomes 12 hours. So start month, December, start day 13, start hours 06. Ensure you edit in line so that it follows this. End month 12, end day 13, end hour 12. So in total, how many hours did you run, or how many hours are we planning to simulate for? How many hours? If you want to do for 6 hours, you write here, run hours is 6 hours. That is if yours is beginning from maybe 000 to 06 or 06 to 12. How do you know? Somebody is asking, how do you know? Namelist.wps. Your namelist.wps should be able to tell you. Another way of knowing, these files which we just linked, they have names. Like mine is beginning with 06, then 09, then 12. So I did a simulation just for 6 hours. So this is another way of knowing quickly. Or you can check your namelist.wps. So once this is edited, run hour is 6, 2025, 12, 13, like this. 06 is okay, 6 is also okay. This is Fortran, so the previous 0 is not counting. You can write 00 or 0. All is 0. Now let's go a bit down here. to the GFS specific settings. The GFS specific settings. The GFS files that we downloaded have specific vertical coordinates. They are 42. The global model from UCAD or from NSEC is 42 levels. So the vertical levels here should be changed to 42. Line 38, the vertical level should be 42. And the number of metgrid levels should be 34. That is standard for the GFS files that we download. When you go to error 5, it's another setting. Okay? Then the physics part, we will not touch today. We will not touch today. You want to take a picture? Yeah, here. These are the things we've changed. E vertical and number of metgrid levels. We will not change anything else. We will not change anything else unless otherwise. Now that otherwise will be something about your domain. If your domain has certain things, we will come and solve. But for now, we are not. No. One more thing to change. We used 3 hours. So ensure that yours is reading here 10,800 and not 216,00. Ensure yours is reading 10,800. Okay. Then this number 20 and 21 is how you want to output the data. Do you want to output it after every 3 hours, after every 1 hour, after every, I don't know. So history interval basically means as the model will be integrating the files which are written out so that you can analyze. Do you want them written after every 1 hour or after every, or do you want one file for the whole time? And for this class, let us get one file for the whole time. So make this number as big as possible. Maybe put 100,000. So those are lines. So as the data is being written, it will be writing the data at those time intervals, which translate to lines of time. And then let us output the history interval as well after every 3 hours, 180 minutes, after every 3 hours, because we are using 3 hours also integration here. So this one should be, we've changed line 18, we have changed line 20 and line 21. You can take pictures. These are basic settings. We have not done any setting for research. We have just done basic. So I've said what you need to do research with namelist, because this namelist is where partly where real research on NWP is, and you will need to understand all the physics if you want to design your own scheme. You design it and then you write a paper on it, and then UCAD will include it, so we can come and refer to it here as number 4, maybe something like that. Okay. So here we go. The defaults are set. I think there's nothing else to change. Be sure that number 38 is 42 and number 40 is 34. Okay. So with these things set and with the files linked correctly, yeah, you save, and then now we come to the wrf.sh. So on the WRS, let us write a few things about what we have done for memory, for remembrance. Number one, we went inside the wrf run directory. Okay, that is the first thing we did. Then we checked by copying. We copied the name list here. It's something you do once. So once you copied it, you don't need to always do it. But be sure namelist.input is copied here. Okay? Be sure. Just be sure. Confirm that it's copied here. So if you're not sure, just copy it from wherever, user, blah, 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 blah. Namelist.input and copy it here. Okay, so I will comment on this because this one is not something you will need to do every time. It will mess up your work. If you copy it every time, you will go back to editing all the details, including the physics that you use. And that will always bring you trouble. Okay? Then this one is just for clearing workspace. Clear previous metgrid files. Just previous files. There are a few others here, like these ones, which we are yet to generate. These two. So this part is just clearing them. Then link most recent met.em files. So we link the most recent files at this step. This part it opens as a certain file which we will use to monitor the simulation in real time. As simulation is happening, we will be able to monitor where we are and how it's progressing. And that is what we are up to today. Okay, so just open a log file for reading the last line. That is what this command is a bash command for reading the last line of any file. So as the log file is written, you read it in real time, and that is how we monitor the progress of the model. So you can choose to open another file, another terminal here. Okay, you can take a picture of these things. Okay. Opening another terminal is your choice if you want. So you can open one, open another terminal. So it has opened my terminal like this. Not just another terminal. It opens a specific file, which you may not have yet, but it opens a specific file called rsl out. This one. Okay. So whether it exists or not, so another terminal opened. Install what? Tail. Install what? Oh, genome. Okay. Forget it. You can open manually another terminal. All right, let's proceed now. With everything edited now, okay, one more thing to test. Test your computer for the number of processors that you have. Let's find out how many processors your computer has, and proc. How many CPUs do you have? Because we want, Dinesh, this WSL one, does it configure in parallel or series? Parallel. We will see. How many? 16. Wow, very powerful computers. Then frog, this one, just on any terminal, just type any frog in. Then tell me the number here. 4. 4, 8. What? 8. 20. 12. Okay. 12. You have 8. Mine has 8. She has 16. And very powerful computers. Now, the ones you need for running a model, like my computer, the one I use at my lab, has about is it from here? So that you appreciate the need for computing power and why we go elsewhere when we are troubled, you know. Okay. So this is my lab computer. You see how many? Yeah. Now that is the power you need, the number of CPUs you need, and you know how long it takes to run for one day? About 6 hours. For so how many of those computers are inside here? How many of your computers are here? So that is the computing power sometimes required for now, like we're doing real stuff. Okay, back to work. Back to what we were doing. So let's run mpirun minus np number of processors, np number of processors. MPI is mpich. Okay, it's for parallel computing, and I don't have time to explain everything. So let me just put the command there. So we want to do parallel computing using all the CPUs possible. Let's not use all of them. Like mine, there are 6. Let's use mine are 8, but I want to just use 6 CPUs for now. If yours is 8, use 6. Yours is 4, use 4. It has to be a number, an even number. An even number. Yours is 16, use 12. Maybe. Use 6. 4 is okay. It's okay. Then real. Where are we running this from? Where are we? In the wrf directory. Okay? In the wrf directory. So I don't know whether I should run this because I've already. It's running, and how to know it's running is that other terminal that I had opened, the genome terminal that I had opened. It's already complete. So if you want to check what is happening, just open another terminal manually and type tail. Yeah, open another terminal to check what's going on and whether there's an error or not. CD home all the way to wrf run. Okay, so once we are inside here, once we are inside here, tail minus f fill this file, and you should be able to read the last line. Tail is for the last line. F is for reading it. What we call forcefully. So as you run real.exe on one terminal, it will show the progress on the other terminal. I'm not coming to solve problems. I'm coming to see how it looks like. Okay. Go and run. Go and you are not running it. Run it. Now go there and see. Not V. R. Oh, quite fast. Okay. So the success message should be like this. At least I've seen a success message somewhere. Where are people?
No problem here.
Where are people here?
Very little power.
What?
Very little power.
No, it's okay. Just run. No. Okay.
Even our metgrid didn't run, so it went off.
Okay. Any troubles here? Where are people?
Real.exe.
There are not enough slots.
I don't know what that.
No. No, my friend, the command is this: mpirun minus np real.exe. That is the full command. This is the number of processors. So if yours is 12, 4, 3, the number of processors. Yes. You are not running anything. You. So whatever 6, 3, 12, this is the full command. Then on another terminal you put this one. Tanimo, how is life? How is life? Too good. Not too good. Use 10.
Right there. I even do 8. Do 8. Just do 8. To save. No,
Just
one
enter.
space.
Just enter. Enter. Okay. Let me bring this computer. So, where's the terminal with the tail? Go to wrf run on this other terminal and type that tail minus f. Go to that folder CD home, the one I've written.
CD home.
And then you type that tail command and you tell me what you are seeing. How are we?
Mine, I found I have a problem with the data. The data I downloaded are not properly. I'm going to try to download another.
No, you are not going to try. You remain here after this class. Okay. We solve this problem once and for all. Yeah. How is life? Tanimu? Did you know? But just was measured what last time? Your metric worked last time.
Yeah. No.
So why are you not running?
No. So I'm good. Problem is now this. I came late today, so I have to.
You've edited this correctly?
Yeah.
Save. Did your metric work last class? Did you reach where people reached last class? Remain here. You're not sleeping today. Remain here. Okay? Yeah, it means it's run. You. I've written tail minus FRS. Why are you not typing the whole thing?
Minus. No, the problem is you write something.
What? Well, I write what?
RF/.
Why are you not typing the whole thing? These are your problems. So read here carefully. What is your problem? Error opening metgrid. You did not link the metgrids here. No, I'm not opening anything. I've come solve problems. Tell me where they are. Where are
They are
they?
in domains.
Where's your domains?
Build up. No, short domain.
What is short domains?
Domain with a small d. They are there.
There are so many of them.
We ran the whole thing from 0.
Okay. You don't see the board from here?
The board?
Those files are not linked.
They were linked.
Give me a mouse. Mouse. No. This is
That's often this time in NUIST. Because I remember linking them.
I just tried to link them now. Did I?
Because the file we are linked, they showed here very well. Like,
This ones.
yeah.
There's something wrong. Something is wrong with the linking. There's another terminal?
Yeah, you see? No. Those are the files.
December 16 was when?
Today,
So you ran this thing again today?
I checked today when I came here to make sure that everything is okay. Because now I've ran it 3 times. I Let's read it with Danish. Last time when you
It's
asked,
okay. It's okay. It's okay.
then
Okay. So the files are not here. You see
they are
that?
not here. They are in domains, small domains from Uganda.
So where's the domains? Back, right? Like this. Uganda.
The files are here.
Are you running a sudo account? 1913. What time is it? So they are here, right? Um, this folder is it? Okay. Right. They're not. Oh, I'm going to kill you after this. Kill you. Bad name, bad whatever. Your name list is the problem. You see? Change these dates. And I think this name list is wrong. This name list is wrong.
But I saw another one. The name list.
You don't just see. Where did you copy it from? Where's Uganda? Domains?
Domain.
This is the one? This is how it looks like? This is the one you created last time?
No, when we are creating domain, it is the nation created.
And that's what I'm asking you. So is it this one you created? This place?
Yes, small domain.
This one is wrong.
But I saw another.
So I will change it for you because you see this one even has to. It means you are running a nested grid. You see these two rows. It means you are running a nested grid. So you need to delete one of them. Change these dates to the correct date. Remove one column. Everything that has two columns, remove the second column, and then change the date. Okay.
Help her. I'm trying to help her, but she's not getting it.
What is the problem?
In the time, no, when we are giving her drawing, what's the problem?
Okay, copy and edit the dates. Then column. What is the problem here?
Yeah, I think it is not at one file because of time difference. When we
1300. Show the.
everything in the list, so
Let's see the name list itself.
yeah, it is.
Is this name list here?
Oh, yeah. The input
From what time? 062?
is first we try to
How
one
can,
thing.
okay,
We
wait.
put 12 and
But how can you run from 06 and then you are ending at 00?
but
How?
we started with 12, it gave the same error.
Start hour, start minute, okay, start date, and end hour, end day, end hour, and minute. And how many hours are these ones?
We are doing so.
6 to 12 is 3 hours. So why are you writing 12?
Hey, I asked her, see, I don't 12 days. She said, that is what she said.
Did you change other things here? Can you run again? Run. Other problems. I want to see this thing here. Then I want this thing run from another place so that I see the error as it's running. So can you go to wrf and run? Edit it. Edit the namelist. Press N. Copy the name list, the right one. Where is it? That one you're saying is right. Where is it? Where is it? Copy. You say this is the right way. Copy it, even if you're copying manually. Copy it to wrf run. I want to see it in the run. Just copy and left. Okay, so for the few that have managed to get the success run, tail rsl.error. So once this is successful, the next is now for you to run the model. So this part now is the final stage, which actually runs the model and gives the output, the final model output. But this one will take quite some time, it will take quite some time. So model mpirun, the number of processors, and then wrf.exe. But this can only happen if you have the real EM successful. Okay? So you can run this, like for your case, you can run this one.
Now it is okay.
Have you changed the date? You've not changed the date.
Because I'd already changed it in the other name list. So when I copy it,
And the day is?
In date.
And hour.
12.
Start hour?
00.
00.
Okay. Go back here. You have many terminals. Whatever is in one place, I don't want you to interfere with it. I want to be jumping on the terminals. Okay? So keep this one open. I need it.
Keep it in
Go to another terminal. Any which is for free. This one is for this. Go to another terminal or open another one. Okay, now go here to wrf run folder. Okay, we go back. Where's wrf? 2 steps, right? Run. I wanted to see these files which we linked. So we have them from 00 to that. So we can even run for 24 hours, but it's okay. Let's run for 12 hours. We should be sure we have edited something else. Yeah, now the model is okay. So we can run wrf.exe. How many cores do you have?
It's 10. It's 10.
Why are you not you can use 16, but of course your computer will be very busy. Can't do it. So you have a problem with mpirun. That thing called mpirun. It's called mpich library. It's not working in your computer. So we will just run your model in what we call serial mode. So you see it's running on serial mode. But if the mpirun was installed, that library called mpirun, use the other cores. So this means if your computer was to be doing serious work, you need, if you would use 10 cores, it will finish in 1 hour. Now if you use 1 core, how long will it take? That is, but it's running. No, I didn't configure your computer. I found a computer installed. So what's the problem here?
And this day after minutes.
It's this one running. And where's the tail part? The tail is saying input date is bad date in name list. No. It's bad date, it's bad date. Bad date is bad date. So do you have the files really?
Remember, we downloaded.
06 from 06 to 12. Okay, now don't, I was not there. You see, we are running from 03. Remove these things first. Where are they? Tell me where they are. In WPS? Mm. Mm. Why are they funny? From 00 to 09. So let's run from 00 to 06. And link all of them still. So the name list. 00 to how many hours? Those are 6 hours. Times out file. You didn't edit these things? Because men, we are not good with multitasking. So wait, I do this, then I'll explain. What happened in this one for 09? Finish? Yeah, it's okay. What are we telling here? finished. Of yours. No, honey. Magara? Hanging. Okay. Complete? No, no. At least we have some people who have managed to complete. That is good news because they will be able to bail others. Then the others can also remain around and we talk, So when the model runs successfully, for those people that when it's running, you don't need to watch it. You don't need to watch it. It's running. It will just write success. Success. What? WAF something, right? When that happens, it will output this data here. And this is what we have been looking for all along, Since day one up to now, what we have been trying to achieve is to generate this data, which is the forecast. We have been trying to generate this data here, which is a forecast. Once the forecast is generated, and yours will finish in a few minutes, yours has finished. They can now be like the Laotians who can help others to also achieve what you've not been able to achieve. So once we have this file, we can post-process it. We can post-process it using so many softwares, okay? The first thing is that the first thing about this data is that okay, so I want people's attention because this one is very important, and this is like the last thing we are doing for the class. I want people's attention. Laoshi, thank you. So once this file is generated, which is the product from after this, we run mpirun whatever wrf.exe. This is the process that does the actual integration. So when we say the model is running, the one that requires the supercomputing facility, it is at this stage. And once the supercomputing is done, we output a variable, we output this data here. So this data can be processed using several softwares. This, for some people, they can use NCL. Yet, for some other people, they can use other softwares. There's even a software that can convert it from this format, which is not the conventional format. Actually, this format is not conventional format, the way you open a netcdf. It's a netcdf file, but it's not the conventional one. So we will need post-processing tools. And the post-processing tools now depend on what you have learned and what you are equipped with. I want to just demonstrate here, and I have shared with you some of these notebooks. I have written some Jupyter notebooks that can be used in Python. to be able to visualize and even process some of this data. And once your simulation is done, you can try. All you need to do is to configure your working environment. Then you will be able to change the paths and show where the data is. So let me go home and deactivate and activate my wrf Python environment. So when Dinesh was configuring your computers, one of the things that was configured was the wrf Python environment. The wrf Python environment. This one was configured for, I think, all the WSL interfaces. So let me, how do we write Jupyter? Let me show you a script which I've shared with you that is able to process this data. You can download it from the file I shared at the beginning of this class. What is Jupyter Notebook? Dinesh, what is Jupyter Notebook? Any ICT person who tell us what Jupyter is? Sorry? It's like Python.
Just ID right now. This is just ID. Some guys might not be like you guys heard about like how it is. You heard about these things like file. Working with this file. And some guys are working with VS Code. And some guys are working with like Jupyter. And like they are like lot of stuff. Even like Python. Some guys are working with Python.
Okay.
These are like programming language, these are like just ID. Yeah, you can write random. These are like interfaces.
Yeah. So long as you have an interface for running Python, okay? So this is a Python script, and where is man? Just a moment. So if yours has finished running, you can actually try with one of these scripts. How did I run it? You just type Jupyter Notebook or Jupyter Lab for those that are running Jupyter Lab. For those that are using PyCharm, for example, you can open it. I think it's a GUI. It's a graphical user interface for the Windows users, right? So you can just open your Python interface and run this script from there. Which are the scripts we are talking about? That is what I was about to show. The scripts are hello. The scripts. So in the folder analysis, the zipped file analysis, you unzip it, of course. I've put for you four scripts, okay? The first one is IMSA post. Let me start with this one, IMSA post convert. What it's supposed to do, it's supposed to convert that file which we have just output from our modeling platform to a conventional net CDF format that now you can go to grads, you can go to CDO and manipulate there, and you can go to NCL and you can go wherever and manipulate. Although NCL and Python can actually read the wrf output directly, but because it's not a format that many people are used to, we need to maybe modify it and convert it in a format that is friendly to most users, you know. So here I'm just importing the packages. I'm not teaching Python in this class. I'm just showing you. And what the script is doing. So this one is not part of the syllabus. We already have the output from the NWP simulation. So just the path and I think, yeah. So this would be the typical data that is from the model. Your date will be different. The way that the file is named, it will be different. For example, yours will be wrfout D01 2025, some date here, right? So you just go and change according to your date. And this part I'm extracting the coordinates because the way the WRF output is written, the coordinates are not the conventional ones that we use in NetCDF. So I'm extracting the coordinates and converting them because I want to rewrite or I want to output this data into another format. And I'm trying some variables, just a few. So for example, I'm trying to output temperature, rain, pressure, the U wind and the V wind. So I'm outputting some of these variables here. I want to write them into a NetCDF format. The specific format is NetCDF4, which is installed in your computers. So when I do this, I get an output, a data set in NetCDF format, the .nc. I think the conversion is still happening. So if you don't have Jupyter, if you don't have whatever interface, you can actually save these scripts as .py and run them on Python directly. Now, for those that are new to Python and new to everything, I think there will be other sessions in future when you will learn other post-processing software. So when we meet next time, and I know we are going to meet next time, you will be experts at post-processing because you will be having the tools required for post-processing. As it's still converting, I can open another script to show how we can maybe, for example, plot one of the variables there. How we can plot one of the variables. So this other script, this one I've written IMSA post rainfall, is able to plot for you the rainfall directly from that output. Yours is working? So we import the libraries and change the working directory in the script. So like, for example, you will need to define where you are working from. I think this path is mine. You will need to edit yours where your extracted analysis folder is. And I don't want to explain a lot. So here we go. This is some plot for my domain, which was Switzerland. You can see there's no rain yesterday. When was 13th? 13th was Saturday. Yeah, you can see there was no rain. It's all snow over there. So that's why I decided to use another file which has data so that you can see how we post-process this. Yeah, our file has been converted to NetCDF successfully. I'm repeating. Sorry. So if you just follow this and change the paths, you should be able to find a long lat plot of your domain, Uganda, Tanzania, and Pakistan, and so forth and so on. Then, so other than the two scripts which I've shown here, the IMSA post which converts the data to another format, and the IMSA rainfall, which plots rainfall for your domain. I've also put here for you some actual scripts that do real stuff. You know, real stuff here now means a bit of like advanced stuff. For example, this one about converting the data, I think it has also some plotting in it. Okay, so let me finish with this IMSA one. So the file is now converted, and you can use it in grads, and you can use it elsewhere for visualization. I wanted to show this one. So maybe a point of may I know, what are some of the variables that you deal with that you want to output or process? Because I've shown you here that the model outputs so many variables. For example, where were we showing the variables? I think here. I just extracted about 11 variables. The temperature, rainfall, pressure, U and V wind, temperature at different isobaric surfaces, pressure, at what we call the perturbation pressure, and pressure at different levels. But the total number of variables, you can see, total number of variables that we output in that simulation which you just completed now, there should be 154 variables. So it would all depend on what you want to do with the output data. The analysis that you want to show with the output data. So here I've plotted some rainfall variables, okay? And because you have exams, so the next 2 lessons we would have spent to, assuming that we were able to post-process the data, we were able to run the model, we would have post-processed the data, but now we don't have time. So I'm just showing you, you can go and try, but there's a day we will meet again here, so that we can post-process slowly, one by one. But I'm just showing you that the file has so many variables, you know, so many variables, and it depends on what you want to show. So this one is critically for those that want to work on rainfall. This one is showing plotting 2 variables, one of them called rain C and another one called rain NC. And what they are, one of them is generated from, let me just say generated from clouds. That would be a very simplified way of putting it, because we generate it using what we call the cumulus scheme. That is, we see how the cumulus convection is developing, and then we extract rain from there. But this other one is generated from what we call the grid scale, the environmental moisture advected, and then we solve for the moisture variable inside those equations in the grid space. Now it's not about the cloud or not. We are looking at the advected moisture in the environment. I think this one would be very technical for you, but I just want you to know that. And by the way, what I'm saying, if you forget everything now, listen to this one which I'm saying. This one is very important. You see, most people think that when we forecast, for example, when I issue forecasts for tomorrow, I will issue a forecast for rainfall, for temperature. These variables, remember, we said we don't forecast them. Okay? We don't forecast rainfall, we don't forecast cloudiness, we don't, these 154 variables, we don't forecast them. We forecast for 7 variables. So where do we get all the other variables, including rain? Rain is not a variable that we forecast. So how do we end up with rain? This is something that puzzles so many people. But I want you to remember that when we were defining the 7 variables in the equation, there was this variable called W, or sometimes we denote it with a small e. What is it? The moisture, we call it the mixing ratio or the saturation pressure. So it depends on which term you use in the expression, yeah? So we are actually just forecasting, let's say, the humidity inside the air versus the actual air. And then we solve the humidity, temperature, pressure relationship within the air itself. And then when the pressure gets to a certain point where the atmosphere cannot withhold it, we drain the air. So the person who was describing these things the way I'm saying them is the person who wrote something called a cumulus scheme that is able to trigger the process of removing water from air. And that process called removal of water from air is what creates rain. I wish we had more time. I would have told you how funny it is that we end up with a variable called rain in the forecast. So anyway, so to get the actual rain forecast, we just take the total of air we have, the moisture we have drained from the cloud and the moisture we have drained from the environment. Okay, and these are the ones. So I think up to this point, we are safe to stop here, because a further continuation will be over. You will be overtasked. So the part which we have not done, we have not post-processed this data, but you have the post-processing script, the Python one. Then we have not said anything about data simulation. We have not said anything about data simulation in this class. So I think for those that are interested, there can be another future time when we sit and try those ones. But all the same, you guys have really tried. It's not easy, it's not easy. When we started, I told you that it's not easy. But you have really tried. At least for those that have been able to even get somewhere. So, my Laoshi, come, and we end this class. My leaders, come and we end this class by thanking these people for showing up, enduring the cold winter, to learn Linux, learn complex things, struggle and get lost, and be found several times. There's hope. Yes. Hmm? Okay. Yeah. I've been asked a very important question. Hey. Shh, 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 shh. I've been asked a very important question. People have come here for 2 weeks, right? Um, how can you use these things in research? That is what somebody has asked me. Anyone has a response? So, yes, try.
something. Wow. So now, I'm doing a chat. Try to use this to do a kind of thing, maybe for presentation. You can run the WAP model. And when you get your result, like how we just get right now, write that result and validate it with what are the applications. Validate it as the result. Then you can write a paper that you can use your WAP here, WAP model to really, really for the account. Something like that.
Okay. What we use the model for is what you have said partly for operations, and for operations that is like the work environment. Now in research you can do the same thing that he has said, but for research. For example, as he has said, you want to simulate a particular weather system. There was a tropical cyclone somewhere, there was some heavy rainfall somewhere, there was snow somewhere. You configure the model and you demonstrate that by configuring the model, and that thing I'm saying configuring is where the research is. So my model, I've configured it like this. These are my spatial resolution domain, setting. This is I was showing you that the name list aspect, by the time you are done understanding everything, you are a top scientist in NWP. So what are all those name list things? You need to understand them, and then you know why am I using the cumulus scheme that is dealing with rainfall like this. So you can change several things. You can change several things in this name list. For example, here, if you understand what these things are, your countrymate, your countrymate, Anselm, yeah. He was a PhD student last year. He graduated last year. The only thing he did, he was working on this part. This is his 3 years of research was on this line. His paper was on this line, what we call microphysics. And he graduated with PhD in understanding the microphysics over West Africa, which microphysics scheme works for West Africa. So remember that what we have done here is at the minimum, it's very basic. We have not gone to change anything in the model. We have just learned this is how you run it. You start like this, like this, like this. Now, real research involves from where we were starting from. There are configuration things. Why did we configure them like that? Why did we choose this data? Why did we use like that? So the understanding of that is where research is. And this was introductory level. So reading is required for anyone who wants to venture into this. But you have the model. This is a very good thing. You already have the model. You already have the data. You need to understand what it is. Then you can change several things along the way, and you do your simulations. Okay. When we meet next time, we are going to discuss more, because even in post-processing, for example, you have 154 variables. For each of those variables, somebody wrote a script on how we process that variable. When we say pressure, what is pressure? So the deep physics around each variable, you can come and define for yourself what a variable is. So you don't need to rely on what other people have defined. But most importantly, where research is in NWP is on this physics here. Scholarly research is on the physics of why are we using the long wave radiation? Why are we using the snow cover model? Why are we using what? Why are we? So this whole part, all this is where research is. Where else research is what we have not covered. So there's no need to mention it. One of them, wrfchem. People who are into aerosol dispersal and the climate change simulations, WRF can simulate trajectories of particles. WRF can output several pollutant variables. Like you have simulations here, for example, 0.2, 0.5, whatever micrometer radiation, aerosols, whatever. Those are variables that once you simulate, you can tell us in future, that is 2 days or 3 days from now, I can simulate this dust, it will go and settle here. And if you can have a model that is able to do that, people will come for you because now you are, the prophet, you're the prophet of the atmosphere. There's what we call WRF solar, which simulates solar radiation for green energy. There's WRF hydro, which simulates the hydro modeling, the flow systems, the river gauges, and so forth and so on. Then there is what I do now, which is WRF data assimilation, which we have not said anything about. And I can't even try to say anything about it. But where it sits, in all this, it sits here. The assimilation, where's the picture that I had shown you? The assimilation part sits between the part where we had done the metgrid level, the metgrid post-processing, and the WRF run. So between this point where we had the boundary data, the boundary data from real.exe, and before you run the model, there's something here, which is a whole field full of so many people. It's called data simulation. So you see, we cannot begin talking about it. Any other question before we finish? We have 1 minute to answer another question. Okay, clap for yourself. If your model has not run, if you don't have the wrfout file, you have to have it. So we can talk aside. Talk to me, find me where I can be found, and you have to run that and get the output so that you post-process, so that your coming here is meaningful. Okay? Thank you.
All right, it's basically a lot of course.